Okay, here is a video about C1 for the vectors unit in MCV4U. Okay, so for C1, we've got 4 things that we have to be able to do for the test that's happening on Friday, February 16th. Okay. Okay, so the 4 things you have to do in C1 are, you have to be able to recognize a vector and a scalar quantity. So a vector, you need to know that it has direction and magnitude, whereas a scalar will just have a magnitude. It's going to have like a length or a speed or something, but it's not going to have a direction. So you have to be able to recognize both of those quantities. So if I give you a description, you could be able to say, hey, that's a vector because, or that's a scalar because. So just identifying which is which. Okay, the second thing you have to know for C1 is how to represent vectors geometrically and algebraically. So geometrically is when we represent them using directed line segments. Like for example, if we had to represent the vector that's going like north 50 degrees east at 60 kilometers per hour. North 50 degrees east. So just being able to like represent it in words and a directed line segment, we should be able to do that. And then along with those, we should be able to know what like equal, opposite, and parallel vectors are. So if I wanted to draw the opposite vector to that, you should be able to do that. So if you wanted to draw the opposite vector to that, you know it's going in that direction. So it would be like south 50 degrees west. And then equal vectors have the same direction and magnitude, and parallel vectors would have the same direction, but not necessarily to the same magnitude. So you should be able to know that. And then representing them algebraically would be using the XY coordinates. So if you had to represent a vector algebraically, you would want to use their x and y components. So if we had this vector, vector v, and we wanted to represent it using the square brackets, like 3, 1, for example. So just being able to represent it algebraically. And you should be able to, okay, so then the third thing is you should be able to convert between algebraic and geometric vectors. So if I give you a geometric vector like, well, let's say we use the one from the above example, so north 50 degrees east and 60 kilometers per hour. So sketch that out. 60 hour. So if we wanted to, if we wanted to convert that to an algebraic vector, we would need to know the x and y components of this vector. Okay, so I know this angle right here would be 40, and if I wanted to get an x and y component, let's get rid of that. So let's say I just wanted to find the x component of my vector, and I want to find the y component of my vector. So to get the x component, I'm going to do 60 cos 40, which is 46 kilometers per hour. Or actually, no. Okay, I'm going to put that. And then I'll get the y component, which is 60 sine 40. So 60 times sine 40 is 38.6. Or I'm just going to say 39. So if we wanted to represent this vector algebraically, we would use our square bracket. Or it would be fine to leave it as like 6 cos 40, 60 sine 40. I meant 60. Okay. So yeah, you could leave it like that or figure out the answer of 4639. So you should be able to go from this geometric vector or just by putting in coordinates. To be able to go the other way around too. So we're given an algebraic vector. So let's say we're given an algebraic vector of 2, 5. So we know that 2, 5 like this. There's our vector. So that's 2, that's 5. So we can just use Pythagorean theorem to get the magnitude of that vector, which will help us get our geometric one. Okay, so finding the magnitude of S is 2 squared plus 5 squared, which is root 29. And you can leave it like that if you want, or you can write it as 5.4. And then we're going to need an angle. So then we can do theta equals inverse tan of 5 over 2. So theta equals 68 degrees. So if we wanted to write this geometrically, we could say, I don't know what the units are, but 5.4 units. North 22 degrees east, if I want to get that angle there. So I can do my north first. So that would be taking this algebraic vector and turning it into a geometric vector. Okay, so that's the third thing we have to know how to do. And finally, this thing that we haven't really done too much work on is just looking at 2 and 3 space algebraic vectors. So we just want to be able to recognize that points and vectors occur in 3 space, which we kind of looked at a little bit. So like x, y, z components. So, you know, we can have a vector in 3 space that's like x, y, z. Oops. We want to be familiar with the whole x, y, z plane, knowing that there's 3 coordinates. And we want to be able to calculate the distance between points and find the magnitude in 2 space. So we just kind of did that on Friday. And FYI, I got to correct something I did on Friday. But distance between 2 points and magnitude of algebraic vectors so we already know we calculate the magnitude of a vector by doing the Pythagorean theorem if we're in 2 space or 3 space. And then to find the distance between 2 points, we kind of said that we're going to subtract x coordinates and our y coordinates from each other. So we know in theory how to do it. So let's just look at an example. So let's say we had a point, so we have point A at 1, 3, and then we have point B at 7, 2. So we've got 2 points. So 1, 2, 3. There's our first point, and then we have a point at 7, 2. 5, 6, 7, 2. Okay, so the distance between those 2 points is going to form vector AB. So I kind of put that notation when we add vectors, but that was incorrect. So here's A, here's B. So vector AB is going to go from A to B. So that vector is found by subtracting our coordinates. So by doing 7 minus 1 and 2 minus 3. Which would leave us 6, negative 1. Oops. And so if you look at that, it does make sense because from A to B, that's 1, 2, 3, 4, 5, 6. And from A to B, we've gone down 1. We've gone from here to here. So I'm just going to switch colors. So that's like our y component is going down 1, and our x component is going over 6. So that's where we get the negative 1 and the 6 from. So this vector right here, vector AB, we can draw it from the origin, and it would look like 1, 2, 3, 4, 5, 6, 1. So vector AB can also be put here. Because remember, vectors don't care where they are, so we can take that vector and shift it down there. So that's the form vector AB. Unfortunately, when I was doing it in class, I think I called that A plus B. So to clarify, this vector right here is the distance between 2 points, A and B, and it forms vector AB, which makes sense, right? So that's how we find the distance between 2 points. And it forms vector B. If we wanted to add vector A, so if I wanted to turn this into vector A, 1, 3, and this is going to be vector B. Sorry, that got messed up. 7, 2. So that's going to be something different. So that's going to be where we can add our x and y coordinates. Because now it's like we're doing, okay, 1, 3 is here. So that's A. And then I'm going to stick B right after that. So over 7 up 2. So there's vector A, there's vector B. And my new vector is going to be like that. So that's going to end up at, well, for A I went over 1 and B I went over 7. So this vector is going to be at 8. And it's going to be up 3 plus 2, so 5. So vector A plus B is just when we add the x and y coordinates, and it's going to form vector A plus B, which is just 8, 5. So sorry, I messed up terminology. So vector AB and vector A would be at 8, 5. And then if we wanted to find magnitudes, so if we wanted to find magnitude of vector AB, find the magnitude of that, we can use the Pythagorean theorem. So 6 squared plus negative 1 squared. So root 39 would be the magnitude of this vector right here. Root 39 is how long it is this length of it. And then if we wanted to find the vector of A, vector A plus vector B, this guy right here, we could just do the same thing. 8 squared plus 5 squared to find the magnitude of vector A plus B. And the magnitude of vector A plus vector B is root 89. Okay, I hope it kind of clears stuff up. I feel like we'll do a little bit more on Monday for this guy right here. But yeah, I just kind of messed up the terminology. And if you wanted to subtract, just since we're on this topic, if you wanted to subtract vector A from vector B, you just subtract their, okay, sorry, so if you're going to subtract vectors, remember we learned in the other unit that that's actually like adding the opposite vector. So we're just going to take A plus negative B. So what that looks like is, okay, so A was 1, 3. And vector B is 7, 2. So we would just take 1 plus negative 7. And then 3 plus negative 2. Okay, so that would make vector A minus vector B equal to negative 6, 1. Okay, and that's how we subtract vectors. Okay, the end of this super long video.